All right, tomorrow we're going to revisit equivalent fractions and comparing. Prefix re. If you reheat the oven or you redo a paper, what does that prefix mean? Again. So this means we've seen them once. We're doing this again. If it's equivalent, E, Q, U, A, L. They're fractions that are equal, not equal numbers. Fractions aren't equal numbers. They're equal amounts. And comparing, as in greater than, 2 dots are greater than 1, less than, 1 dot is less than 2, or are they equal? So we're reviewing this. All right, there are many ways we can find equivalence. Remember that we can use a multiplication table or models, or we can cross multiply. So we're going to use multiple methods. So right here, what fraction is shown? Well, fractions have a numerator and a denominator. D, what are we divided into? Fifths. Know what you're looking for. I'm looking for shaded. 1, 2, 3, 4. So we are 4/5. Not a whole amount, a part. All right. It says multiply numerator and denominator by 3. So you're going to record your fraction, 4/5. And 4 groups of 3 is 12. And 5 groups of 3 is 15. And this is what I call the rule. What you do to one, you have to do the other. If you multiply the numerator by 3, you have to do the same to the denominator. That's the rule. What you do to one, you have to do to the other. Now, I would pull a multiplication table out, and I would tell them to go to row 4 and row 5. And if you think about that, it would look like 4, 8, 12, 16, and then 5 would be 5, 10, 15, 20, right? So go find row 4 and row 5 and move over 3 times. That's 1, 2, 3. 12 15ths, see? It's equal. If you jump 1, 2, 3 4s, to be equal, you would jump 3 5s, 12 15ths. So I have it on, this is another reason we make multiplication charts. All right, we have models, which I didn't catch these shaded. I think I caught other shaded amounts. Poop. All right, well, you can kind of tell that this is shaded and this is shaded. What's up, babe?
That's 12 and that's 9.
So I'd read this. And then what are we looking for? We're looking for a comparison that is true. Well, let's label. What is this model? Well, LaDonna is 6/9 and Kylie is 9/12. Looking at the shading, can you see if one has more shading than the other?
That's
Which one? Kylie?
yes.
I agree. She has more shaded, which makes this one greater. So I can just use the model. So I know 9/12 is greater. They're not equal. Right here, 9/12 is greater because 2 dots are more than 1. Now, what if I'm not sure? Maybe it doesn't look quite equal. Well, let's cross multiply. 12 across to 6. What is 12 times 6? 72. 9 times 9 is 81. Is 81 greater than 72?
Yes.
Yes. 2 dots are greater than 1. This is correct. Bam. All right. We're looking at these number lines. We want to know, is Ryan correct? Justify the answer. Justify means prove. Well, what did Ryan said? He said he ran 5/8, which is exactly, Lenny, go get me my charger, which is exactly the same. Please, babe. Well, let's log in 3/5. 3 as in 1, 2, 3 jumps out of 1, 2, 3, 4, 5. There's 3/5. This is J for Jennifer. 5/8. 1, 2, 3, 4, 5 out of 1, 2, 3, 4, 5, 6, 7, 8. Did they run the exact... Thank you, babe. Did they run the exact same amount? I don't know. I mean, to me, it looks like 3/5 is a little bit
A lot.
less. Well, what can I do to see if they're exactly the same? Well, let's cross multiply. Let's grab 3/5 and let's grab 5/8.
Wow.
5 across. 5 groups of 5 is 25. 8 groups of 3 or 3/8 is 24. So are they exactly the same?
No.
No. Justify. Well, here's my proof that it doesn't quite line up, or there's my proof. All right, over here, here's that rule. The rule. What you do to one, you better do to the other. So, I can go to 5 to 10. How many 5s does it take to make 10?
2.
So if you do times 2 with the denominator, you better do times 2 with the numerator. So 2/5 is equivalent to 4/10. Again, you can go get your multiplication chart and show them. All right, 3 to 18. What times 3 is 18? 6. Well, if you multiply or jump 6 3s to be equal, you better jump 6 2s, which is 12. Again, go show them the multiplication chart. 4 goes down to 1. So 12 needs to go down, decrease.
Decreasing.
Or I could think 1 to 4. 1 times 4. 4 divided by 1 or 4. So it's divided by 4 or times 4. So you could think what times 4 is 12? 3.
Wow. Ah, 2.
All right? I don't want to go down. I don't like decreasing. So I'm going to think 3 to 9. 3 3s is 9. If you do that to the numerator, do it to the denominator. What times 3 is 18? 6. So that's the rule. And what are you using? You're using multiplication. Why does multiplication give us equivalence? Well, because if you're jumping 2 groups of 2s to be equal, you jump 2 groups of 5s. Down here, use your multiplication table. We're going to list 4 equivalents. So you're going to go to row 3 and row 9. Well, 2 3s is 6, and you're going to find that's on 6/18. And then if you jumped 1 2 3 3s, you'd be on 9. 3 9s is 27. So this is all on the multiplication table. Over here, now we're going to use multiplication. Well, multiply what you're good at. Like, I know 6 times 2 is 12. How do you be equal? Well, if you're going to jump 2 6s, you better grab 2 7s, which is 14. What can I multiply by? Can I multiply by 5? Yep. If you have 5 6s, that would be 30. To be equal, you better jump 5 7s, which is 35. Ask a kid what's something I can multiply them by to find an equivalent. They might say 11. All right. Well, if you do 11 groups of 6, to be equivalent, you better do 11 groups of 7. What else can I multiply them by? 10. What's 10 6s? 60. To be equal, what's 10 7s? 70. So when I want an equivalent, what do I need to do? Multiply. Multiply by what? The answer is anything, as long as you're being equal. And you can use your multiplication chart. You can use the rule. You can multiply by anything to make equivalents. The big thing that I found that works with the kids is just reminding them that it has to be equal. And on your multiplication chart, you really can see that. All right, we're going to use the bars. So I'd ask the girls to read. Boys, what are we looking for? A fraction not equivalent. 2/3. Well, I want to find 2/3. How many of these thirds do we need? 2. So there's 2/3. So 4/6. 1 2 3 4. Is this equal? Yes. I don't want it. I want the one not. 6/9. 1 2 3 4 5 6. Is 6/9 equal? Yes. I do not want equal. Is 5/8 equal? 1 2 3 4 5. 1 2 3 4. Is this equal? No, there's the one. How can I prove it further? And I would definitely do this. Let's cross multiply to prove it. 8 times 2, 16. 3 times 5, 15. Not equal. Not. All right, boys, read us about Marquis. We want equivalent fractions to a half. Is 2 half of 4? You said yes. How do you know? Yeah, because 2 plus 2. Is 3 half of 6? How do you know? Because 3 plus 3 is 6. Is 5 half of 9? No. How do I know? Because 5 plus 5 is 10. We said 2/4 was good. We said 3/6 was good. Is 4 half of 8? Yes. How do you know? Because 4 plus 4 is 8. 3/6 is good. Is 6 half of 12?
Yes.
How do you know? Because 6 plus 6 is...
12.
So 2/4 is good, 3/6 is good, 4/8 is good, 6/12. So the best answer is J. All right. Down here, Jackie has a paper clip that's 10/16. Give me a kiss, baby. I love you. Night, night. I'll be there in just a second. All right, so we want an equivalent fraction with a denominator of 8. Well, if you can't tell, these are all 8. They're all 8. So, first of all, what fraction is shown? Well, what do fractions have? Numerators and denominators. Well, D, what is my whole inch divided into? 1, 2, 3, 4, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Know what you're talking about. Well, we're on 8, 9, 10 sixteenths. I want to know which one of these is equivalent to 10 sixteenths. How can I figure out which one of these is equivalent to 10 sixteenths? I could look at a multiplication table. All right, we'll go to the smaller numerator. 4/8. Row 4, row 8. So we'd have 8 and 12 and 16 and 20, and you'd have 16 and 24 and 32 and 40, right? So is 4/8 and 10 sixteenths? Well, is there a 10 on the 4 line? No, not equivalent. All right, what's another way I can find out if they're equivalent? Multiply. Multiply how? Cross multiply. Nope, I don't want to try cross multiply yet. What about the rule? How does 5 become 10 times 2? Well, if you do that to the numerator, is 8 times 2 16? Yes, there's your answer. Could you cross multiply? Yes, you can, but I try to make them think other ways too. All right, he has an array of pennies. So we want an arrangement that has an equivalent fraction of tail side up. All right, well, how many pennies here are tail side up? 1, 2, 3, 4, 5, 6 out of 2, 4, 6, 8, 10. So this is 6/10. I want one of these sets to be equivalent to 6/10. Well, how many of these are tail side up? 4/5. Cross multiply. 30, 40. No. 1, 2, 3 out of 5. Do the rule. How did 3 times 2 is 6? Is 5 times 2 10? Yes. There it is. The rule, what you do to one, you do to the other. All right. We want the fraction that names part, Kara, Eaton. Liz and Kara each bought 12. Liz ate 3/4, Kara ate less than Liz. So I need something that is less than Liz, less than 3/4. So I need to know which one of these is less. How can I compare? Cross multiply. 8 times 3, 24. 6 times 4, equal. 3 times 3, 9. 4 across to 2, 8. Is 8? 8 is less, right? 1 dot is less than 2. So 2/3 is less than Liz. There it is. And then the last one, you want something equivalent to 10/12. Well, how can I find out if 5/6 is equal? I could go to a multiplication chart. So row 5, row 6. Is everything ready? So we want to know if 5 6 is equivalent to 10 12ths. You have to go to the smaller numerator. 5 6. 10 12ths. Bam. That's it. How else could I check? Cross multiply. All right. Well, yep, that'd be 60 and 60. So that is tomorrow. And they do have an assignment tomorrow also.